Have you ever looked at a chemistry problem and thought, okay, but how much concentrated is this stuff? Because in chemistry, it's not just about what a substance is, it's about how much of it is packed into a certain amount of solution. That's where concentration comes in. In this video, we're going to break down the 5 major ways chemists describe concentration. Molarity, with a capital M, is the moles of solute per liter of solution. Molality, written with a small m, denotes the moles of solute per kilogram of solvent. Normality, with a capital N, is the number of equivalents per liter of solution. Think of equivalents for an acid as the number of H pluses that are available. And for a base, it's the number of OH negatives available. Percent concentration, just written with a percent sign, is how much out of 100. Mole fraction, written with a small x, is the ratio of moles in a mixture. At first, these might seem like a bunch of formulas to memorize, but they're actually just different ways of counting particles in mixtures. And here's the really important part. Once you understand what each one means, converting between them becomes way easier and less scary. So in this lesson, I'll define each type of concentration clearly, show you what they physically represent, and then walk you step by step through how to convert from one to another. By the end of the video, you won't just be plugging into equations, you'll actually understand what those numbers are telling you about a solution. Suppose you are given a concentrated solution of HCl, which is known to be 37% HCl and has a solution density of 1.19 grams per milliliter. So what are the molarity, molality, and mole fraction of HCl? Begin with the assumption of 100 grams. So if I assume 100 grams, then you know that there's 37 grams of HCl and 63 grams of water. To find molarity, you need to determine the moles of HCl per liter solution. So let's first convert the known amount of HCl, which is 37 grams, into moles. So moles HCl, I know that I have 37 grams times 1 mole. HCl has a molecular weight of 36.5 grams per mole. That means that we have 1.01 moles HCl. Next, convert the known mass of solution. So I have 100 grams of solution. So let's convert that into liters. So I have 100 grams. I'll multiply that times the density. And since I have grams, I need grams on bottom. So I'm going to put 1 milliliter on top. And the 1.19 grams of solution on the bottom. And this has to be in liters. So I'm going to say 1 liter over 1,000 milliliters. It tells us that we have 0.0840 liters solution. Since the moles and the volume of solution are now known, we can calculate the molarity. So capital M, molarity, is equal to moles of solute over liter solution So that means that we have 1.01 moles of HCl over 0.0840 liters solution. That gives us 12.0 molar HCl. From the information above, let's find the molality of the HCl solution, which is the moles of solute is already known to be 1.01. We also know that we have 63 grams of water. Let's take this 63 grams of water so 1 kilogram of water over 1,000 grams. That will give us 0.0630 kilograms of water. So the molality with a small m is equal to moles of solute per kilogram solvent. So this will equal 1.01 moles HCl over 0.0630 kilograms water, which will give us 16.0 molar HCl. Finally, let's tackle the mole fraction of HCl. So the moles of HCl is known to be 1.01 moles, so we need to find the moles of water. So moles of water, it's going to be 63 grams of water times 1 mole water over the molecular weight of water, which is 18.0. So we have 3.50 moles of water. The mole fraction, I have the moles. The total moles will be the moles of the HCl plus the moles of the water. I have 1.01 moles of HCl so 1.01 moles HCl plus 3.50 moles of H2O. If I add both of these together, I get 4.51 moles total. So it would be 1.01 divided by 4.51, which gives me 0.224. This is the mole fraction. Mole fraction does not have any units. Given a 1.75 molar sodium hydroxide solution having a density of 1.040 grams per milliliter, determine the molality, the percent sodium hydroxide, normality, and the mole fraction of sodium hydroxide. I prefer to break down everything that I think I'm going to need before I get started trying to solve the problems. So let's do that. I have 1.75 moles of sodium hydroxide. Let's convert that into grams. This gives me 70 grams of sodium hydroxide. And we have the density here. Let's convert that density into mass of solution. So the mass of solution will be the density times volume. So that's going to be 1.04 grams times 1,000 milliliters over liter. That's going to give me 1040 grams of solution. If I subtract my 70 grams of sodium hydroxide from this, I will have 970 grams of my solvent, which is water. I can then take this 970 grams of water and I can convert this into moles of water. Molar mass of water is 18. So this will give me 53.9 moles water. Okay, so let's find our molality. So molality is going to be equal to the moles of solute over the kilograms of solvent. So I have 1.75 moles of sodium hydroxide. We said earlier they have 970 grams of water. Let's move the decimal 3 places over. So that'd be 0.97 kilograms water. So that gives me a molality of 1.8 molar sodium hydroxide. Okay, for the percent. Okay, I have 70 grams of sodium hydroxide. And my total solution was 1040 grams. And let's multiply that times 100. That will give me 6.73% sodium hydroxide. For the normality, it's the number of equivalents. Sodium hydroxide has one equivalent. So therefore, N is going to be equal to M. So therefore, it's going to be 1.75 normal sodium hydroxide. For the mole fraction, I have the moles of solute over my total moles. And we say we have 53.9 moles water. So it gives me 0.0314 for my mole fraction. And that will be for the sodium hydroxide. Given a sodium hydroxide solution with a mass percent of 0.01000, find the molality and the percent sodium hydroxide. First thing I want to do, I want to assume 1 mole solution. That means I would have 0.1 mole sodium hydroxide, and I would have 0.9 moles of water. So 0.1 moles sodium hydroxide. Let's convert that into grams of sodium hydroxide. The molecular weight is 40 grams per mole. That means I have 4 grams of sodium hydroxide. 0.9 moles of water. So that's 18 grams of water per 1 mole of water. That means I have 16.2 grams of water. So 4 plus 16.2 means I have 20.2 grams of solution. Okay, so now let's see if we can solve for molality and percent. All right, so molality, small m, equals the moles of solute, which is 0.1 moles of sodium hydroxide, over kilograms of solvent. I have 16.2 grams of water. If I move the decimal 1, 2, 3 places over, that would give me 0.0162 kilograms of water. That would mean then that I have a 6.17 molar sodium hydroxide solution. For my percent sodium hydroxide, I have 4 grams of sodium hydroxide and 20.2 grams of total solution. I need to multiply that times 100. That means I have a 19.8% sodium hydroxide. What are the mole fractions of glucose and water when 50 grams of glucose is dissolved in 100 grams of water? Okay, so let's get our background first. I have 50 grams of glucose. Let's convert that into moles. So 1 mole C6H12O6 is 180 grams. That gives me 0.277 repeating moles. I have 100 grams of water. Let's convert that into moles. 1 mole of water is 18 grams of water, which gives me 5.55 repeating moles water. So we're solving for the mole fractions. So the mole fraction of C6H12O6 will be the moles of this, which is 0.277 repeating over 0.277 repeating plus 5.55 repeating. So this will give us 0.0476 for the mole fraction of C6H12O6. The mole fraction of water will be 1 minus 0.0476. So X for H2O will be 0.952. The density of 4.50 molar solution of sulfuric acid is 1.122 grams per milliliter. Find the molarity, the mole fraction, and mass percentage of the solution. Okay, so first of all, let's try to find some good working numbers. 4.50 moles of H2SO4. Let's convert that into grams. So that'd be 98.1 grams for sulfuric acid, which gives me 441.325, or 35 rather, grams of H2SO4. Alright, since it's molality, I automatically know that I have 1 kilogram of water. (1,000 grams of water). Alright, so if I add those two together, I would have 1441.35 grams of solution. That's the total mass of all the solution. Okay, I'm going to find the mass percent first. Okay, so the percent by mass for H2SO4 will be the mass of the H2SO4, which is 441.35 grams, divided by the total mass of the solution, which is 1441.35, times 100. That would give me 30.62% H2SO4. So the percent by mass of water, that will be 100% minus 30.62%, which is 69.38%. Okay, so next thing let's do, let's find the mole fraction. So the mole fraction for sulfuric acid, I have 4.5 moles over the total moles. Okay, so the total moles, I have 4.5. Now my water, I have 1,000 grams. If I divide that by 18, that will give me my moles of water. So that's going to be 4.50 divided by, okay, this will be 55.5. So 4 plus 5.5 will be 60.06. So for my sulfuric acid, that's going to be 0.075 H2SO4. Not going to fit. If I say 1 minus this, that would give me 0.925, which is the mole fraction for water. To find the molarity, I'm going to start with the 1441.35 grams of solution. I'm going to multiply it times the density. So 1 milliliter is 1.122 grams. Grams cancel, which gives me 1284.63 milliliters of solution. I can then scoop the decimal 1, 2, 3 places over, so I would have 1.284 liters of solution. Then to find molarity, molarity is equal to moles of solute, which was 4.5 moles of H2SO4 over the liters of solution, which is 1.284 liters solution. And this would give me 3.5 capital M molar H2SO4. That'll be the molar concentration. Concentrated sulfuric acid has a molality of 189.36 molal and a density of 1.84 grams per milliliter. Find the molarity, normality, percent sulfuric acid, and mole fraction of the sulfuric acid. All right, so let's get started breaking this down. I'm going to start with the 189.36 molar. That means moles H2SO4 per kilogram of the solvent, which is going to be water. Let's go ahead and convert that into grams of H2SO4. I know that 98.1 grams is the molar mass of H2SO4. That's going to give me 18576.2 grams H2SO4. If I add my 1,000 grams of water, which is 1 kilogram, that will give me my total mass. So total mass is going to be 19576.2 grams. Let's also take that 1,000 grams of water. Let's convert that into moles. One mole of water is 18 grams. That's going to give me 55.56 moles water. Let's take that density and let's get liters of solution. Okay, so I have 19576.2 grams of solution. Let's multiply it times the density. It's 1 milliliter per 1.84 grams, which gives me 10639.2 milliliters of solution, which is 10.6392 liters of solution. All right, so first of all, let's solve for molarity. Large M. Molarity is equal to the moles of solute, we said was 189.36 moles, per liter solution. We found that to be 10.6392 liters. That gives us 17.8 molar H2SO4. Okay, let's solve for normality. Normality is equal to the number of equivalents times the molar concentration. So my molar concentration is 17.8. And since this is H2SO4, there are two H's here. Okay, so I'm going to multiply that times 2 equivalents. So that will give me 35.6 normal H2SO4. For the percent H2SO4, okay, I have 18576.2 grams of H2SO4. And my total mass will be the 18576.2 grams plus 1,000 grams of water. Got to multiply this times 100. That will give me 94.89% H2SO4. For mole fraction of H2SO4, I take my total moles, or my moles of H2SO4, 1857. No, that's wrong. What am I doing? It'd be 189.36 divided by 189.36 plus the 55.56. That's going to give me 0.773 for my mole fraction. So today we didn't just learn a bunch of new formulas, we learned different ways chemists describe how much is mixed with how much. Whether it's molarity, molality, normality, percent concentration, or mole fraction, each one gives us a slightly different lens for looking at the same solution. And now you know how to move between those lenses by converting from one form of concentration to another. If this video helped, please click the like button and subscribe to the channel if you haven't done so already. Make sure to practice a few conversion problems on your own. That's where the understanding really locks in. Thanks for watching, and I'll see you in the next lesson. Thank you again.